of the easiest problems is where you're giving already given the formula. Right? So suppose that z equals x to the fourth y cubed, where both x and y are changing with time. At a certain instant, when x equals 3 and y equals 1, x is decreasing at a rate of 4 units per second, and y is increasing at a rate of 6 units per second. How fast is z changing at this second? Right? So they give us a little hint, and we'll have to use the product rule, but hopefully you'd recognize you've got two variables. We don't really need to identify our variables, but let's identify, let's just identify what x and y are going to be when we plug in. So x is 3, y is 1, and we don't know z, but that's all right. If we wanted z, we could just, it'd be 3 to the fourth times 1 cubed. So it would be 81, but we don't really need z. But if you want, we can write it down. And dx dt is decreasing at a rate of 4 units per second, so that'd be negative 4 units per second. Y is dy dt is increasing at a rate of 6 units per second. So dy dt equals 6 units per second. And dz dt is what we're looking for. So obviously none of these are staying constant. Right? We've identified, so when we do the plot, when we substitute back, we know what our values are going to be, although we're not going to need the z. I wrote it in anyway. We will need x, we will need y, we will need dx dt, we will need dy dt, and when we finish solving, we'll have dz dt. Our equation is pretty simple, it's right up there. So z equals x to the fourth y cubed. All right, so let's take the derivative. All right, so we do have a product rule here. U is going to be x to the fourth. The derivative will be 4x dx dt. V is y cubed. dv will be 3y squared. Oops, how did we lose the 4x cubed? Sorry, du is 4x cubed dx dt, left off the exponent. And then the derivative of y cubed is 3y squared dy dt. All right, so now we can just take the derivative. dz dt equals, so the first, x to the fourth, times the derivative of the second would be 3y squared dy dt. I'm going to move these up just a little bit. Plus the second, which is y cubed, times the derivative of the first, which is 4x cubed dx dt. Let's clean this up a little bit, and then we'll just substitute in. dz dt equals, let's put the 3 first, 3x to the fourth y squared dy dt plus 4 x cubed y cubed dx dt. Yeah, just put them in alphabetical. All right, so now all we need to do is just substitute our values. So dz dt, if I have enough room to squeeze this in, I should really try to write smaller, equals 3. X was 3. Y is 1. dy dt is 6. Plus 4 times 3 cubed, 1 cubed, and dx dt is negative 4. I'm going to scroll up and give myself a little bit more space. If I can find the cursor. Which I can't. I'm afraid I'm going to hit the, maybe I can hit it right here. Oh, there it came up. There we go. All right. I don't want to hit the recording box. I can't, when I can't find that cursor, if I start just hitting around, I might hit the recording box, and there goes my recording. All right, so dz dt equals, all right, so This would be the same as 3 to the 5th. That's going to be 343. The times 1 isn't going to change that. Or excuse me, 243. 243 times 6. So that's 1,458. And it's going to be a minus because we have one negative there. All right, so we've got 3 cubed is 27. And then we've got 2 4s, so 27 times 16. And of course, then 1 cubed isn't going to matter. It'd be 432. So dz dt equals 1,026 units per second. All right, and there we go. There's the rate and change of z. Oops. That's not where it goes. So here's the rate of change in z when x is changing 4 units in the negative direction and y is changing 6 units in the positive direction, and maybe one day my c will come up. I don't know. Anyhow, there we go. To 1,026 units per second, and that's the end of this problem. So thanks for watching. Bye for now.